taking that thing, we are developing polyvalent anti-TNF antibody. For that, we have generated a nanobody, novel nanobody sequence by using the custom service. The lead nanobody sequence was engineered to make it trivalent. Remember, our conventional antibody are bivalent. We are making it trivalent and pentavalent to see whether we can make it or not. Lab scale process is developed, and the purified protein shows binding on ELISA, that it is binding. So we have reached till this stage, and further characterization is still going on. In another discipline, we are developing anti-IL-23 and anti-TNF alpha bispecific. So we have engineered a protein which can bind to two inflammatory marker, IL-23 and TNF alpha. We have produced it by using PK expression system, and we found that they are binding to the ELISA of both of these antigen. So these are all, both of these are very promising molecule which we want to take ahead further. This is the developmental stages of other programs. So 3 of them are tested in animal and few of them are in process. I will conclude that engineered protein is really bringing a new era for protein biopharmaceutical innovation, and as we have been told to move beyond biogeneric to the innovator molecule. Innovator molecules are difficult. They take time and money. In between going from moving ahead from similar to innovator molecule, biobetters can be an interesting halt where we can concentrate. Indian research ecosystem should take note of this, that there are 20-50 proteins available which can be upgraded, and if we can develop them, then that can be a little achievement. I would like to thank Department of Pharmacology, Professor Sharma, Professor Tikku, Professor Jena. They are collaborator and they are expert in characterizing this molecule what we are developing in the Department of Biotechnology. If you have any queries, I am open to it. Thank you.
Yeah, thank you. Thank you, Dr. Pande, for detailed overview on the biopharmaceuticals as well as the ongoing work, which is interesting up to the lab scale. Lot of process has been developed on a number of candidates, and I think now you need the industry partner for the further scale up and the commercialization. Yes. I know developing the innovative biologicals are always challenging because they are not biosimilar, so you need to develop all the methodologies for the physicochemical characterization from the scratch, because you don't have any comparator here.
True.
And so considering that, have you developed completed all stability data?
No, we have not done that.
Okay.
Stability, toxicity data are yet to do. We are planning to do it in couple of.
So I think prior to the animal studies or parallel, you have to initiate some stability data.
Yes.
So you can have the idea what type of the storage condition you need.
I agree.
And if you have some advantage over there, it will be more interesting.
I agree.
Yeah. So the seminar is open for any questions. Yeah.
Thank you.
So my question is, did you try the protein engineering, just cloning them, expressing them, and then immunization or DNA vaccine? So did you try both route for production?
We have tried the first route, producing them, purifying them, and testing them.
No DNA. Okay, sir. Another thing you told that nano antibodies. So pentavalent you want to produce that. Why do you think that will be more efficient than divalent? Because naturally they are producing divalent only, right? So why you want to produce a pentavalent?
It's better if we have more binding site. Also in nature, a YDP when IgM is produced, mentioned that sometimes avidity also can be used. If you have more multiple binding sites and if you have low affinity, that also can be compensated by high avidity. And not only me, the other players with other antibodies, they are doing crazy engineering. I myself, when I look into those molecules, I cannot believe whether anybody can produce such molecules.
Now, SCFB, you can have you compared with the values of the SCFBs. So, how?
SCFBs is another platform
Yes.
for antibody segment.
So, and nanobody and SCFB, which has a more affinity and which should work better?
Nano antibodies are smaller,
Yes.
15 to 20 kD small. SCFB is relatively bigger. FAB is more than that. Full length is more than that. So depending on your interest of pharma, one can look into it. Which one is better? Which one is not better? That should be checked. But I'm sure conventional monoclonal antibodies are going to be replaced in near future very soon.
Thank you, sir.
Interesting talk, Dr. Pande. So, I have a couple of questions on anti-TNF alpha. So, when you are making bispecific or multivalent, you are doing it in situ or you are doing this coupling in cell-free medium first. The second question is about choice of your expression system. Is there any specific reason why PKA, why not mammalian cell, which can give you, particularly with respect to post-translational modifications, glycosylation and all? So what is your comment on that?
Thank you. For first question, no, we are designing a gene. We are not doing in situ, we are not doing coupling of protein. We are designing a gene and expressing it as a single polypeptide and producing it. And for second, after E. coli, PKI is the next step. Of course, we want to go for other cellular expression system as well. So we are planning to do that as well.
So, last question is, with respect to anti-TNF alpha, you know that it's one of the top selling drug in the world, Humira. So, and so many players are there. So how you position, where you see that the molecule which you are developing is going to be. And another important point, particularly using anti-TNF alpha antibody in developing country, the place where TB prone areas, because there are clinical reports that using anti-TNF alpha antibody in the arthritis, people have seen that significant number of TB resurgence. And that's a big issue why anti-TNF alpha antibody is not so popular in developing country, particularly in India.
For your first question, where I want to see myself in this field, see my hunger is very big. I want to go ahead as much as I can. Somewhere we have to start with the right strategy to make it more viable for industrial usage. If it shows promise, yes, we will go wherever we need to go. But for that, we are producing the panels of molecule and checking it. Regarding your second question, the use of anti-TNF in the some part of the globe, I am not expert in that. I am a biotechnologist. I am producing a protein. If it is used, then that's it.
Thank you.
Last.
Thank you, Dr. Pande. For me, it's a lot of data to look at. I come from the background of biotechnology, quality control and assurance. I have just a suggestion for you because you have big dreams and you want to grow. I think you need to fix up your technical SOPs. Please don't take it otherwise. I saw many slides. If I look at your SDS page gels, even since your Kumasi blue gel, it's looking in different colors, and all backgrounds are pretty blue, and you might miss out some fine proteins out there. And I also saw some of your proteins sitting in your wells. So please get your SOP right. I understand that there may be many students working with you and they may be doing little variations. One of the simplest thing which your students have to do or your faculty has to do is just filter all your solutions before you use them and spin all your samples once you've digested. You'll get better gels. And there is also spillage from one well to another. So why I'm saying this is because I saw your endpoint where you want to file IND. You know, if you want less questions from IND reviewers, you need better presentation. So please get it that way. Thank you.
Thank you. Yeah, thank you, Dr. Pande. And on the behalf of the organizing committee, I invite you to receive the memento.